This is a question on Equilibria. It's an 8-mark question in 4 parts, A to D. So have a go at each section and then review the rest of the video. Here's part A, part B, and parts C and D. Okay, so going back to the beginning and taking a look, we have got here an expression for the equilibrium constant Kc for this reaction, and you are told specifically to use X and Y rather than the full structures of those compounds. So I am putting products on top. I am remembering that my H2O is squared because I'm using the balancing of the equation, 2H2O. Products over reactants, and once again my methanol concentration is squared because it's 2CH3OH, and we've got our first mark, part A. Moving on into part B, and we're given some equilibria values here, some initial moles and equilibrium moles. And as always, I'm going to draw out my table. I've got my reactants and products in there, and I'm now going to fill in everything I can based on the question that's been provided. So I was given the initial moles of X and of CH3OH, and I've been given the equilibrium moles of Y. Now, I can assume I started with none of the products, so 0Y and 0H2O. I've also added in red the balancing of the equation. So 1 mole of X reacts with 2 moles of methanol to make 1 mole of Y and 2 moles of H2O. And from there, I can use this data to piece together the missing data. So, for example, if 1 mole of X makes 1 mole of Y, 0.26 moles of X will make 0.26 moles of Y. So my X goes down by 0.26, giving me an equilibrium moles of 0.06. If I move on to the CH3OH, 2 moles of methanol make 1 mole of Y. So I would need 0.52 moles of methanol to make 0.26 moles of Y. So I go down by 0.52, giving me 0.32 moles. And for the final one, I'm going to compare methanol to water, because that's a 2 to 2, therefore a 1 to 1 ratio. 0.52 moles of methanol will make 0.52 moles of water. I've got my third mark. In terms of the calculation, I've brought forward the Kc expression that we were using earlier, and I'm now going to substitute the figures in. Once I've substituted those figures in, I can do the calculation and I can get a value of 11. My Kc is 11. Now, in terms of the units, there are no units. And that's actually because I've got mole d m to the minus 3 cubed on top and mole d m to the minus 3 cubed on the bottom. They cancel out entirely. So 1 mark for the working, 1 mark for the Kc, and 1 mark for the units. Now you'll notice I've brought the delta H information forward from the equation we had earlier. And we're going to use that to predict the effect on Kc if the reaction is carried out at a lower temperature. Well, if delta H is negative for the forward reaction, a lower temperature will favour that forward reaction, giving us more products. Now you'll notice I'm putting some red arrows on the Kc expression at the top because that means concentration of products will go up and concentration of reactants will go down. Now if the numbers change in that way, that means that Kc has increased.